The fourth theorem claims, or it states, that angles in the same segment are equal. All right. So you will notice, the first thing that you notice is that these angles are on the circumference. We are talking about angle A and angle B. They are both on the circumference. So that this theorem only applies if those angles are on the circumference. So you can't have something like this, and then you cannot now claim that this angle is equals to that angle because this one is not on the circumference. So remember, theorem 4 only applies when the two angles lie on the circumference. So angle A and angle B are both suspended by a chord or arc PQ. So because now they are both suspended by PQ and they fall on the one side of the circle, we're calling them angles on the same segment. So that means they are equal. That means angle A is equals to angle B. So how do we go about proving that one? All right. So we're going to create a center, a point on the center then, and then let's name our center O. All right. And then we will join PO. We will also join OQ. All right. We join OP and OQ. Okay. So what do we know? We learned that angle at center is twice angle at circumference. We learned that from theorem 2, so we're going to use that. All right. So that means, let's just name it angle O1, or O is fine, or O1. I will just put a 1 here so that when we say O, we're not talking about the whole revolution. So that means O1, according to theorem 2, is equals to 2 angle A. If we divide both sides by 2, that means angle A is equals to half O1. Half O1. Angle O1. Remember, we always have to give reasons. So our reason here is going to be theorem 2, which is angle at center is equals to 2 times angle at circumference. Angle at circumference. All right. And then focusing on angle B now, we can do the same and say we know that angle O1 is equals to 2 times angle B. And it's the same reason, theorem 2, which is angle at center is equals to angle at circumference. I forgot center here. There's supposed to be center here after at center. Angle at center is 2 times angle at circumference. Don't forget the reasons. You always state your reasons. All right. So if we divide both sides, also, we do get that angle B is equals to angle half O1. If you go and divide both sides by 2, that is basic geometry, you will get that B is half angle O1. Notice that angle A and angle B are both equals the same magnitude, angle A and angle B both equals to half or 1. So since both of them are equals to the same thing, that means then that angle A is equals to angle B. That one was easy to prove. Okay. So the converse of this theorem then would be that if you find two angles that are equal that are on the circumference, so remember, it's either two angles, you are given that angles are suspended on the same segment, then you're going to conclude that, okay, they are equal since they are on the same segment. So if you are told that there are two angles that are on the same segment, so you check, okay, they are suspended by the same chord, and then you're going to conclude that that means those 4 points A, B, P, and Q are concyclic. Remember, concyclic means that all four are on a circumference. This will help us a lot when we have points that are not visibly seen on a circumference, but then we are required to prove quadrilateral, or we need something on a circumference. As soon as we find two angles that are on the same segment, or we are given on a statement that these two angles are on the same segment, then we're going to check for 4 points that are concyclic, and that might help us a lot. So that is a converse of theorem 4, is that angles on the same segment are equal. The converse is that if we have angles that are on the same segment, then all 4 points are cyclic. So this is also the same even if the chords are separated. Let's say you have a circle and then you have something like this. Let's have another one here. Something like this. And we are told that this chord is equals to this chord. Then that angle then will be equals to that angle, provided that both angles are on the circumference. So the reason is that angles on the same segment, again, that's the reason, because they are suspended by the equal chords.